So we have seen plate tectonics. We know that there is crust, mantle and core. In mantle, you have asthenosphere or magma chamber, from where the liquid actually comes out and it pours in the form of lava. We have seen till there, but let us see what exactly is the definition of this. So if you see volcano, what is a volcano? Volcano, unlike many people think, the magma or lava comes out is not volcano. Volcano is just a structure, where you have a vent or opening through which heated materials consisting of gases, water, liquid lava, and fragments of rocks are ejected from the highly heated interior to the surface of the earth. So if you take this pic, which looks like volcano, here you will usually have rocks being present and a small gap opening, and the pipe which is actually present inside is actually called as volcano. Volcano is a vent or opening through which materials consisting of gases, liquids and all actually comes out to the surface from deep interior to the surface. Then what are the other materials which come out? You actually see lava. Magma, once it comes out on the surface, is known as lava. Gases, ashes, ash, tephra, that is crushed rocks, pieces of rocks. Why does gases come? Water vapor and all is actually seen. If you see a lot of greenhouse gases, they are also emitted through the volcanic chambers. Why gases are usually emitted? How does it usually come out? It is believed that whenever the plate tectonics actually happen, the oceanic plate, which is heavier, submerges deep into the continental plate, isn't it? So whenever oceanic plate subducts, in that space water goes down, and due to high temperature which is present deep inside, the water is evaporated and it comes out in the form of various gases. So that is why it is important for us to know what all comes up and what is the reason for it to come out. So gases, water vapor. How is water vapor present in magma? How does it come? It is mainly because of the water which subducts below. Then what is vulcanicity? You would have heard the term. Vulcanicity is a process, covers all those processes in which molten rock material or magma rises into the crust or is poured out on its surface. Right? What does it mean? Vulcanicity covers all those processes in which molten rock material or magma rises into the crust or is poured out on its surface, there to solidify as a crystalline or semi-crystalline rock. So vulcanicity means magma temperature increasing, it becoming less viscous, coming out, pouring out as lava, solidifying as rock. All these is known as vulcanicity. So vulcanicity includes liquefying and magma coming out and pouring as lava. What is volcanism? All the phenomena connected with the movement of heated material from the interior towards the surface of the earth. Magma moving from deep inside the earth, that is from the mantle till surface, is known as volcanism. Coming out from the beginning, coming out and becoming rock is vulcanicity. Volcano is just a vent, right? These are the major differences. Then if you see the pic, right, can you see you have divergent boundary? I have always told you, whenever you see arrow marks, you understand what type of boundary it is. So you have divergent boundary. So whenever you have divergent boundary, what happens? Magma flows out. And when magma flows out, you usually see mountains being built here. So you actually have divergent boundary, and wherever there is divergent boundary, you usually see mid-Atlantic ridges being formed. Mountains or volcanic eruptions are actually seen, ocean ridge, right? Then you see this particular region, that is convergent zone, where subduction is actually happening. Whenever subduction happens, what happens usually? So Whenever subduction happens, this particular portion of the earth is actually going into mantle, right? In the mantle, it is heated further. Here, this particular portion is also becoming magma. Here in this region, if you see, the quantity of magma is increasing, isn't it? See, you have a lot of magma being present. Let us take the black color to be magma. So whenever more magma happens in this particular region, then over a period of time, the magma rises. So what has happened? Subducted, that land is melted, magma quantity increased. When magma quantity increased, magma started flowing here, right? It got accumulated, it started flowing here. When it started flowing here, the land which is usually near to it, right? Near to it is melted and the magma flows out in the form of volcano, isn't it? So what is it? So whenever in convergent boundary due to subduction, the continental plate or oceanic plate goes deeper, they are actually melted, and whenever they are melted into magma, they rise. When the volume rises, they rise, and when it increases, usually what happens? There it eats the continental crust and volcanoes are usually formed. So near converging boundary, you also see volcanoes which are closer to subduction zone. Wherever you see trench, right? You have trench here. Wherever you see trench, decide that if you see mountains, one possible reason for that is the subduction and volcanic mountains. So this is the actual stuff that you need to focus on. So next, let us see what are the causes of volcanic activity. Yeah. What are the different reasons why volcanism actually happens? One thing is seafloor spreading. What is the meaning of seafloor spreading? We have seen the theory where Henry Hess was actually talking about seafloor spreading, isn't it? So seafloor spreading, the new oceans is created and magma pours out to form new ocean crust. So that is one. And the major reason is plate tectonics, divergent and convergent. In both sides, you see volcanic mountains. Mountain building process, which I actually explained, right? Wherever subduction happens, their mountains or ridges are usually formed. And the other reason is that gradual increase in temperature with increasing depth. That is 1 degree centigrade rise for every 32 meters. So at a depth of 48 kilometers, the rocks are molten, and the reason for this is radioactive materials. So as temperature is increasing, magma is formed. So when more and more magma is actually formed due to subduction of the plates, then it has to come out. So it comes out in the form of volcanoes. Origin of magma at the subduction zone. I have showed you. Origin of gases and vapor due to heating of water which reaches underground. I told you whenever the plate submerges, it actually water enters, and in that area you usually see that the vapors are formed. Water vapor is formed, and there in those volcanoes you see the vapors coming out, gases coming out. Movement of plates mid-oceanic ridges is the best example. Types, I have told you volcanic eruptions can be of different types. One is quite fissure eruptions. In the divergent plate, when the two plates are moving away from each other, magma comes out, it pours, it solidifies to form rocks. So it is divergent plate boundary. Basalt, which we see in the mid-oceanic ridge. Other one is explosive, where convergent boundaries are actually seen. Right? You have Benioff zone or subduction zone. The subduction zone where the crust actually goes into the mantle is known as Benioff zone. And the best example is Circum-Pacific Belt and Mid-Continental Belt. So based on the type of eruptions, usually volcanoes are divided. Whether fluid magma flows out or whether viscous magma flows out. See, whenever you have fluid magma, let me take crust. There is opening vent here. Okay. When fluid magma, when I say, what happens? It flows. Keeps flowing, isn't it? So the spread is more. But if you have bit viscous, it comes up and forms a cone. And it starts flowing. So can you see the difference in this? In the first case, you are actually seeing that it is spreading. In the second case, it is making a volcanic mountain. So, usually based on the eruption type, what type of magma is coming out, different shapes are actually seen. If you see this Hawaiian eruption, which is actually observed, this is the first type, Hawaiian eruption, because of Hawaiian Islands, the eruption is seen near that, we call it, in this, you actually see great quantities of extremely fluid, basic lava flow out from the fissure. What does it mean? That is a fluid. When I say fluid, I told it is spread. So you usually see that there is a shield volcano. What is shield volcano? If you have crust, it is actually spreading across to form a shield. It is usually shield volcano rather than a cone. Why? Because it is more fluid. So when it is fluid, when liquid magma is coming up and pouring out freely, then why do you see explosions? Explosions are very rare in Hawaiian type. Fine? This is the first thing. The second thing you take is Strombolian eruption. It is because of the Stromboli of North Sicily, Italy. Based on the different mountains, we actually name the eruptions. So here, basic lava is less fluid and fragmental material is ejected. So, in the first thing, we saw the fluid one. So, it is not explosive. But if you take Strombolian eruption, here you actually see fragmental material. That means rock pieces and all. So, when they are actually ejected, usually what happens? Explosions are most common. Third, Vulcanian eruption. What does it mean? Lava surface solidifies rapidly because of high viscosity. That is, as soon as it erupts, it solidifies. Like, you form a rock, whatever is coming, you have a crust, whatever is coming is getting solidified. So remember, when viscosity increases, solidification is quick. When viscosity is less, fluidity is more, then usually you see spreads happening. If fluid is more, it takes less time to condense, so particles may be, granules may be more. But whenever you see the other way around, that is quickly solidifies, then usually you see glassy type and all, isn't it? So that is mainly because if you see Vulcanian eruption, lava surface solidifies rapidly because of high viscosity. Magma, whichever is coming, is solidifying quickly. So a series of violent explosion and pyroclastic materials are ejected. So as it solidifies quickly, see, one came, it blocked. Again the another one will come, again magma rises, right? Again there will be a blast. So that's earthquakes also we saw, right? So the same thing is happening. So pyroclastic material means ashes and all. Large quantities of ash is ejected and they form large dark cauliflower-like clouds. So Vulcanian eruptions, the most common thing you see is the cauliflower type eruptions or clouds being formed. Pelian eruptions. Pelian, in this, the example is because of Mount Pelee, which is present in West Indies. So in Pelian eruption, what actually happens is, you usually see a glowing cloud. Can you see here? The cloud whichever is coming up, it is hot. Something is burning there. Some house or something is burning, and when fire comes up, it looks something like that. In this, it is extremely viscous. Again, high viscous, so you see explosions again. Plinian eruption, greater violence, because The explosion happens so rapidly. Viscosity is more. So when viscosity is more, it blocks quickly. Whenever it blocks, the pressure inside comes up, it heats and throws open. When high viscous, it is low viscous. What happens? Only one layer of block is formed. If it is more viscous, two layers is formed. If it is much more, then three. Maximum four. So if I have to break all these four domes which are actually formed, plugs, usually we call it as plugs. So the plugs which has formed, if I have to break it, the pressure which I have to put is more. So more viscous it is, more larger the plug is. When larger the plug is, then the pressure is more, and when pressure is more, usually the clouds come out of to great heights. So in Plinian eruption, usually you see that eruptions are more common, and there the gases come out and forms clouds till great extent. Explosion cloud towers to considerable height in the shape of pine tree. Can you see this? So if we see everything together, Plinian has more. You have Pelian less but fire. Vulcanian cloud forming. Strombolian more eruptions, rocks and all comes. Hawaiian cool, isn't it? Cool. So this is the different types based on the eruptions itself. On the basis of materials ejected, again volcanoes can be divided. So if you see, the most common one is basalt cones. They are rare and are likely to be low rather than high because of fluidity. I told you that usually in seafloor spreading and all, what happens? Volcanoes come, magma comes, pours out as lava and it cools. So shield is formed. So when shield is formed, you don't see ridges or mountains of great height. So can you see these are smaller ones? It's not big as other volcanic types. Example is the Rangitoto and Jalbrite in Iceland. Basalt domes are shields. One, you saw basalt cone, which form cone shape. Domes, small one. Or shields, which spread. It is formed where fluid lava is extruded. Wherever fluid lava is coming up, they form shields or domes, smaller one. Small blocks kind. Humps, can you see on roads? That kind. Example, Hawaiian and Mauna Loa. Mauna Loa and Mauna Kea are the highest mountains. Ash or cinder cones. Okay, so here the cone shape, can you see this, is usually made of ash. Eruptions are explosive. When it is explosive, then only you get ash and all, with predominance of pyroclastic material. Obviously, if you have to have ash, it has to be pyroclastic. Does not attain heights greater than 100 meters. Why? Ash, it spreads out. Right? Whenever there is great explosions, it's fall apart rather than staying at one particular place and forming a cone. Composite or stratocones. What does it mean? See, in one layer you have ash, another layer magma, another layer ash, another layer magma. So this is actually known as composite or stratocones. Alternating sheets of lava and pyroclastic materials, and these are most commonly seen. Why? The reason for that is actually, first you had volcano happening, fluid coming up, again there was a block. Then you had blast and ash coming up. Again you had fluid passing on. Again block, blast happening, ash coming up. So this continuous process, alternating periods of quiet and explosive eruptions, has actually led to composite or stratocones. World's larger volcanoes such as Fujiyama and Vesuvius are the examples of stratocones. Yeah. On the basis of periodicity, what does periodicity actually means? Time frame, right? It is not that volcanic eruptions happen continuously. Every day you don't see volcanic eruptions happening. It takes time. So based on that, volcanic eruptions or volcanoes are actually divided into active volcanoes, dormant volcanoes, extinct volcanoes. What is the meaning of active volcano? Constantly eject lava, gases, constantly, every time you see. The best example is Stromboli, and that is the reason this is actually called as lighthouse of Mediterranean Sea. Which volcano is the lighthouse of Mediterranean Sea? Stromboli. Then dormant volcanoes. See, volcanic eruptions have been seen, but it has become extinct. When I say it has become extinct, from last 60 or 100 years, from last 1 century, I have not seen eruption happening. But it may happen. I don't know. From last 100 years, it has not happened, but it may happen. And people now they predict by seeing the seismic tomography. So if the hot lava or magma is present inside, it may come up anytime, right? So you should be careful. What is the best example? Vesuvius or Kilimanjaro. Please see, where is Kilimanjaro? It is actually present in East Africa, and it is the largest volcanic eruption which is seen there. And it's the only mountain which you see. Extinct volcanoes which function in a distant geological past, and there is no longer any volcanicity. You actually see that deep inside the earth, the magma is not hot and it is not creating much trouble outside. So extinct volcano, some generations back, it was there. When you see how this mountain has been formed, you feel that, okay, this is formed because of volcanic eruption. But recently, you have never heard that there was a volcanic eruption in this particular area. So historical past, if it is not noticed, you call it extinct. You know that there was a volcanic eruption in this, then you call it dormant, but it is happening continuously, you call it to be active. So what are the associated structures? Whenever volcanic eruptions actually happen, few structures are formed. It is not that when volcanic eruptions happen, you don't see any structure. I told you cone, shield, plucks and all. Let us see what are the different structures which actually form. We have seen what are the different types of rocks which are associated, right? Lapoliths, laccoliths, batholiths and all. But here we need to see through volcanic eruptions what type of structures are seen. First is volcanic craters. What do you mean by volcanic craters? Crater, can you see this? Funnel shaped, right? So funnel shaped basin surrounding the vent. This is vent, the deeper one. Okay, the funnel which comes up. You have this, and due to flow, it has become like this. Right? So this is vent, volcano, and volcanic flow has actually happened like this. You usually see very steep inward facing cliffs. What does it mean? The inward faces. We have already seen what cliff is, where you have a horizontal or steep slope, isn't it? So inward facing, where the vent is actually there, you see cliffs. Lava lakes or layers of ejected material is usually observed in this region. That is, lava lakes, see the region, if water is filled there, they become lakes, or you may see ashes and other thing is being present in that region. So in the crater, you may actually observe lakes or ejected material. Calderas, very large crater. Crater, smaller one. Calderas, very large crater. Why does it form? It is formed mainly due to coalescence of several smaller craters. See, once there was a crater. Again there was a volcanic eruption. Again it became a bigger one. Again there was a volcanic eruption. So due to this, usually you see that you have calderas being formed due to collaboration of the small craters. And here the common phenomena is repeated explosions. See, first it was here, and again due to explosion, again due to explosion. You usually see this, that is repeated explosions. Collapse, what does collapse means? Due to faults that is happening, divergent plates, faults actually happening. You see that the middle portion goes down and it is going deeper. So due to this, calderas may happen. If you see this pic, see, you have two fault lines, you have the structure in between, and this is actually going down. Fine. And it is going down, but it is protected by the magma flow which is coming above. It is not allowing, there is a basaltic plastic one which is formed, which is not allowing the caldera to go down. So the best example is Yellowstone caldera, right, in United States, where you see that you have a basalt which is blocking and the earth crust is coming down, right? It is going, but it is prevented from further going inside, mainly because of the layer which is usually there. So you can see here stopping of surface rocks by a large underground magma chamber. So the underground magma chamber is actually protecting the land to be above. Ash showers, but if more and more heat actually increases, then what happens? Usually you observe that this portion is also dissolved. So in these regions, tomorrow you may see small gaps forming up and mountains forming, or if it spreads, a new ocean can come. First, rift valleys come, and then seas come, and then oceans are actually formed, isn't it? So this may actually happen. Ash showers, where you usually see that lot of ash is coming up continuously due to explosions and deep inside particles being melted. Volcanic mud flows, whenever the magma flows up, lava comes out, and if there is heavy rain associated, usually the heavy rain tries to mix with it and it spreads. So the mud flows, the soil or magma which is associated, when it comes up, mixes with water and flows and spreads across the place, you usually call it mud flows. Mud flows or lahars are caused due to heavy rain and new ardenti deposits that we saw, lightning, ashes and all coming. So ashes is coming, heavy rain is there, all this ash actually spreads out, isn't it? So ash and water mix, when it flows, it look like mud flows. Mingling of new ardentes with river water. So there is a river nearby, and due to ash explosion, so usually it went and it fell in the river nearby, and the entire river flow will look like mud flows. Emptying of lakes by ash deposits. So if there was a lake, right, and ash is actually happening, you had a caldera or crater, and suddenly you had the ash flow happening, and when ash is mixing and water is pouring out, so you have a lake, ash is filling in, so the entire lake is filled with ash. So the water which is coming up, it looks like mud flows. Snow and ice melt on ash. So you have Iceland and all, where if ash is coming up and you have snow and ice which is melting and it is mixing with ash and form mud flows. So volcanic mud flows, how are these formed? Heavy rain, river, lake or snow and ice melt. The simple form. Water, when it mixes with ash, it forms mud flows. Plug domes, as I have told you, whenever it hardens, see here, it's coming, it is getting hardened in this dome. Plug is actually formed. Whenever the plug is actually formed, we call it plug domes. It blocks, and then you see violent explosions actually happening. When does this happen? Viscous lava does not spread or flow, but form cylindrical or cumuloplugs in the crater of a volcano. That is, in the vent and in the crater, you usually see that there is a dome. You know, it has viscous, and the solidification has actually happened in the vent itself. Whenever the solidification of the magma happens in the vent, we call it to be plug domes. The lava-filled volcanic pipe is called volcanic neck. So if the pipe is filled with lava and it has solidified, we actually call it volcanic neck. Sulfur terrace, very important one. Usually UPSC may ask, what is sulfur terrace? Or sulfur terrace is associated with what? The reason is, first few things everyone knows. If you see plug domes, you people can understand. Volcanic mud flows, people will understand. Ash showers, they may understand. Yellowstone, all these, but Sulfur-terras, usually it looks like some acid rain or something. Usually this is where I have seen majority of the people doing mistakes. So I'm telling, this is the question where if I give, majority of you will do wrong. What is sulfur-terras associated with? So it is the late phase of volcanic activity prior to the extinction of the volcanic cone. So you understand that if sulfur-terras is actually coming up, then there is extinction of the volcano happening quickly. What is actually happening? Gentle emission of sulfurous gases and steam without violent explosions. Gentle emission of sulfurous gases. Sulfurous gases is coming up and steam without explosions. Only gas is coming up. Like, after all, everything is buried. Like, you get gases coming up, right? The same way, you see this pic where you actually see that it's the end stage and just the fumes are coming up. The next thing that is important is geysers. So what exactly is geysers? You might have heard this term. What is a geyser? A violent ejection of steam and superheated water. Steam and water is actually coming from underground source through a hole in the ground. See, let me think a scenario. You have volcano here or magma here. Okay? And this is a crust. Have small hole somewhere here. Magma. And in this layer, underground water is present. This water is heated. Some water source is there. Underground water is present. And this water source is heated continuously. So when it is heated, it comes out in the form of steam or superheated water. So this is actually known as geyser. Usually you see geysers in New Zealand, Iceland, Yellowstone Park, which we saw, and then Caucasus Mountains. Next, we'll see what is hot springs. Hot springs, it's like your bathtub, hot water filled. Can you see this? It's just like a hot water bath. If you just type hot springs, you see that people are actually enjoying. They go there, take bath and all in this region. But if it becomes hotter, you cannot. Sometimes water does not rise in the geyser. See, if steam happens and if it pours out, you call it geyser. Sometimes water does not rise in the geyser, but hot water flows continuously from a spring, common in volcanic regions. So from a hole or something, you usually see that you have hot water flowing continuously. In India, hot springs are observed in regions where there is no volcanic activity. Usually, hot springs are common in regions where there is volcanic activity. In India, it is actually seen in regions where there is no volcanic activity also. So hot springs is not a phenomena associated only with volcanic activity, but it may be associated with other processes also. That is, you have a source. As you go deeper, temperature increases. So there is a place where water is there and it is heated and it is coming out in the form of hot water. Simple. So it need not be associated with volcanic eruptions alone. Fine. So in India, where all we see? In Sona, Haryana, Rajgir, Puga Valley, Ladakh, and Anantnag, Kashmir. So usually you see hot springs in this region. UPSC may also ask map-based questions from this. So please be prepared with this. Fine. So till now, you saw earthquakes, you saw volcanoes, you saw rocks and all, isn't it? So these three chapters are either you get direct question, factual question. When I say direct question, what is volcanicity, what is earthquake, what is alien mountains and all, factual points they may ask, right? So please be prepared for this. You won't get many confusing one. What is evaporates? Factual question. Okay. What is sulfur terrace associated with? Factual question. So directly they may ask you the factual question rather than going in detail. So in these 3 chapters, that's why I didn't give you much questions. So please be prepared, and whatever I have told is more than enough. So if you can go through this and remember them, examples and types are most important. So just ensure that you are good in that. Thank you.